Hi everyone! By the end of this video, you will be able to calculate the length of a chord, either a chord, a diameter, or a radius, okay, or the distance to a chord using Pythagorean Theorem. So we talked about angles in circles. Now we're going to go and talk about some more lengths of circles. But first I wanted to note a couple of theorems that may have come up already. I haven't talked about them yet because they are kind of obvious just by looking at a picture, but I want to make sure we're all on the same page. So the first theorem has to do with chords and their arc. Okay, just to talk about the theorem, it says in the same circle or congruent circles, two minor arcs are congruent if their corresponding chords are congruent. So in plain English, what this means is if these two chords are congruent, then their intercepted arcs are congruent. So the intercepted arc of AB would be this one, and for BC would be this one. So if these two chords are congruent, then we can also say their intercepted arcs are congruent. Which again, if you just look at this picture, you can kind of tell. Like these arcs look the same length, the chords are marked the same length, and you can kind of visualize that. So to repeat that, the arc AB is congruent to the arc BC if and only if their corresponding chords, so chord AB, is congruent to chord BC. If the chords are congruent, the arcs are congruent. If the arcs are congruent, the chords are congruent. Another theorem says if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and it also bisects the arc. So what that means is I see that this is the diameter and this is a chord and they're perpendicular, which means they meet at a right angle. If that happens, then this diameter bisects the chord. If you bisect something, that means you cut it in half into two equal pieces. So that means these two pieces here would be congruent. So I've marked those as the same marking, means they're congruent. It also says the diameter would bisect the intercepted arc. So this is the arc that's created by the chord. So the diameter would bisect that arc. So that would also mean this is congruent to this. Okay, so to put this into a statement, if all this happens, the diameter is perpendicular, makes a right angle, and DE is congruent to EF, then also arc DG would be congruent to arc GF. Okay, so these would be congruent, and these would be congruent. Okay, so now for some problems for today. We're going to learn how to find chords and distances given different pieces of information. So for this example, you have a 24 centimeter chord and a 20 centimeter radius. And it wants to know how far from the center of the circle is the chord. So I'm just going to start by drawing a picture. Okay, so I have a 24 centimeter chord. Might look like this. I can draw whatever chord I want. Like I could have drawn it out here as well. I just picked somewhere to draw it. Doesn't matter where. Okay, I could have also drawn it here. I just picked a chord. So if this is a 24 centimeter chord, okay, you also know the radius is 20 centimeters. It wants to know how far the chord is from the center of the circle. So what I'm really trying to find is how far is this chord from the center of the circle. Okay, now if you read our objective for today, the way we're going to do this is we are going to find distances using Pythagorean Theorem. In order to find Pythagorean Theorem, well, let's just recap what Pythagorean Theorem is. Pythagorean Theorem, I'm just going to abbreviate that, is a squared plus b squared equals c squared. And what this formula does is it finds missing sides of right, make sure you write this down, of right, only right, triangles. But I don't have a right triangle in this picture, so I'm going to need to set up this information in such a way that I can make a right triangle. So I'm going to draw in my radius because I was also giving that information. So again, the chord is 24 centimeters. The radius is 20 centimeters. So I'm going to draw that on the picture. And I could draw the radius wherever I want. A radius is just from the center to the edge. So this could be a radius, or like this could be a radius, or like that could be a radius. But I want to use Pythagorean Theorem, so I want to draw the radius in such a way that I start to construct a triangle. In order to do that, I'm going to need to use this line and the radius. So if I draw the radius so it connects to the edge of the chord, I start to have a triangle looking shape, which will be helpful to using Pythagorean Theorem. So again, I could have drawn the radius here. That's still a radius, but this way of drawing it is going to help me set up a right triangle. So that's 20 centimeters. And what it wants to know is how far is the chord from the center of the circle. So I want to know this distance here. And again, I could draw this in a few different ways. I could draw this line over here and say that's how far it is from the circle. But I want to create a right triangle, and a right triangle needs a right angle. So I will make this perpendicular to the chord, so now I have a little right triangle here. I want to find this distance. How far is a chord from the center? And the reason I told you these theorems before is because really I'm going to apply this theorem. So if you have lines that meet at a 90-degree angle, like right here, then you automatically know that the pieces of the chord are congruent. So since this, and technically I could draw this as a diameter, right? Like I could extend this line all the way through. Since that is perpendicular to the chord, I know that this piece is congruent to this piece. So that means that 24 will be cut into 2 equal pieces. So this will be 12, and this will be 12. And now I have a right triangle that I can use Pythagorean Theorem on to find that missing distance. So I'm just going to redraw that right triangle, kind of rotate it. Actually, I don't even need to rotate it. I'll draw it exactly how you see it there. So my radius is 20 centimeters. Okay, this piece of my right triangle, right here's my right triangle. Now the whole thing is 24, but this piece is only 12 because I got bisected or cut in half. And I'm trying to find the length of the distance between the center and the chord, which is this side. You can call it whatever you want. You can call it question mark. I'll just call it x. Okay, and here's my right angle. Okay, so a squared plus b squared equals c squared. Keep in mind that a and b have to be the legs, and c has to be the hypotenuse. So the hypotenuse is always the one that's across from the 90-degree angle. So 20 is my hypotenuse. So to set up this equation, I will have 12 squared plus x squared equals 20 squared. Okay, and if I simplify that, I have 144 plus x squared equals 400. Which if I subtract 144 from both sides, I can go ahead and get x alone. So doing that, these cancel out, and I get x squared equals 400 minus 144, which is 256. Now to get x alone, the square is bothering the x. So to undo a square, you take a square root, not divide by 2. It's not multiplication. So the square root cancels out the square. You're just left with x, coming up here. The square root of 256 is 16. So that means that the side of this right triangle is 16, but it also means 16 is the distance from the center to the chord. We want to put units back on that because we're talking about a distance. So I want to know, did you go 16 miles? Did you go 16 inches? No, we went 16 centimeters. So you need units. Okay, now here's a similar example, but you're trying to find something different. So if you read this problem, it says a chord is 12 centimeters away from the center, and the chord is 10 centimeters long. In this problem, it wants you to find the radius. So this problem, we have the radius. The next problem, we want to find the radius. So let's set up our picture, and I can do this however I want. So I know we have a chord, and the chord is 10 centimeters long. Okay, so this blue line is 10 centimeters long. And I want to find the radius. So again, I could draw the radius here and say how far is that, but like these are disjoint, and it doesn't help me solve a problem. So I want to start to set up a right triangle so I can use Pythagorean Theorem. So I'm trying to figure out how long the radius is. So this will be my unknown. Okay, I can call it x, I can call it y, I can call it z, it doesn't matter. Okay, you also know that the chord is 12 centimeters away from the center of the circle. So the distance between this chord and the center is 12 centimeters. Okay, and that would make a 90-degree angle with the opposite side, because if we make a 90-degree angle, then we know that this chord is bisected, so each piece will be 5. Okay, so similar problem, except this time you are trying to find the radius. So I'm going to go ahead and redraw my right triangle off to the side here so I can just focus on the numbers I have. We got a chord that looks like this. Okay, my right triangle is here, so it's only half of the chord is the base, is 5. This is 12, this is my right angle, and I'm trying to find the radius this time, which is the hypotenuse because it's across from the 90. So this case, you'll set up 5 squared plus 12 squared equals x squared, and solve for x. So 5 squared is 25, 12 squared is 144. And again, you can plug this in your calculator, but I know these off the top of my head. Add those together, you get 169 equals x squared. Again, to solve that, you're trying to get x alone. A square root undoes a square. Those cancel each other out. And the square root of 169 is 13. So x will equal 13. But again, I was trying to find the radius of the circle, so make sure you answer the question. The radius is x equals 13 centimeters because we're trying to find a distance. Okay, so again, you could have drawn the radius and the chord wherever you want, but you want to set it up strategically so you can use Pythagorean Theorem and construct that right triangle. Last example, and then you'll try some on your own. A circle has a radius of 25 centimeters. A chord in the circle is 15 centimeters from the center. How long is the chord? Okay, so let's go ahead and draw that. I want to find out how long the chord is. I don't know how long it is. I'm just going to draw a chord, and I don't know the distance of this chord. But I do know that the radius is 25 centimeters. So radius goes from the center to the edge of the circle. And I know that that is 25 centimeters. I also know that the chord, and I should highlight this, I know the chord is 15 centimeters from the center. So the chord isn't 15 centimeters, but the distance to the center from the chord is 15. So that makes a right triangle here. And I want to find the length of this entire chord. But in order to do that, I can only use the right triangle stuff. So I can only find the length of this distance right here. So let's set that right triangle up right now. I'm just going to spin this around to make it a little bit easier to look at. Here's my picture. Here's my right angle. Across from the right angle is at 25. Okay, one side of the right triangle is 15. And I don't know the length of this blue side. Not that that's the length of the chord, but I need to find this distance to find the whole chord. Because whatever this is, this piece will be the same. So 25 is my hypotenuse, so my equation would be set up as 15 squared plus x squared equals 25 squared. Go ahead and calculate that and try it on your own, and I'll come back with the answer. Okay, so I just showed you my work, but you should have tried this on your own. If you did it correctly, you got x equals 20. Now, that is the distance of the base of the right triangle, which is right here. But I want to know how long the entire chord is. Okay, so if this is 20, then I know these pieces are congruent based on the theorem we talked about, so this would also be 20. That means the length of the whole chord would be 20 plus 20. Combine them. So the length of the chord would be 40, and I'm talking about centimeters in this problem. Okay, so three different situations. One you're solving for a chord, one you're solving for the radius, one you're solving for the distance, but they all focus around can you create a right triangle and use Pythagorean Theorem, and then you know some distances in circles. So with that said, these are for you to try on your own. Please ask questions if you have them.